Hello everyone, welcome to CodeWeb India. So in today's video, I'll be explaining how to solve this Leetcode problem, maximum depth of N-ary tree. So we're given an N-ary tree that looks something like this. We need to find its maximum depth. So what is this N-ary tree? So an N-ary tree is basically a special type of a tree that has a property that the root node is allowed to have n number of children, right? So we know that binary tree is only allowed to have two children at most. Then we have binary search tree, which is a special type of binary tree that holds a property that always the value in the right subtree will always be greater than the root's value, and the values in the left subtree will always be less than the root's value. Then we have this N-ary tree. So in this N-ary tree, the root is allowed to have n number of children. As you can see here, 1 is having 3 children and this particular node 3 is having 2 children, right? So we need to find its maximum depth. So what is this maximum depth? So it is mentioned here, the maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Okay, so the root node is this, and the longest path is this, or it can be this. The length of these paths are equal. It is basically the number of nodes that we encounter along these paths, right? So this and this, 3 nodes we encounter. That is why the longest maximum depth of this particular tree is 3, right? Again, let's just go check for this example. This is the root node. We encountered different paths are possible here, but we can see that this is the longest path, the most number of edges, and the depth will be the number of vertices 1, 2, 3, 4 and 5, right? So let's just basically look at this in this particular diagram, right? So as you can see, this is the exact replica of this particular example. So 1 is the root node, 3, 2, 4 and children of 1, and 5 and 6 are children of 3, right? So how do we approach this problem? How do we basically, calculate the maximum depth? We have two techniques. The first one is called Bfs and the second one is called Dfs. So Bfs is short for breadth first search and Dfs is short for depth first search, right? These two techniques are widely used to basically traverse every node of a single tree, right? So what is Bfs? Let's just first consider Bfs. So Bfs is short for breadth first search. So what it does is basically traverse each node at each level and then goes to the next level, right? So first it will go to this level, root node, it will traverse this one, then it will go to the next level, then it will traverse all the nodes at this particular level, right? Before going to the furthest level, right? So it will traverse 1, then it will go to 3, it will traverse the other nodes at the same level, then it will go to 2, then 4, and then after it has traversed all the nodes at a particular level, it will go to the next level, so 5 and 6. And if it tries to go to the next level but this is null, so basically we return the control and we return to the root and we return the final value, right? So this is how Bfs usually works, and in order to use Bfs we have a queue to maintain the left child and the right child, or in this particular case we have an N-ary tree, so we maintain the all number of childs or store the all childs inside the queue, right? And let's just now look at how Dfs works and what it is actually. So Dfs stands for depth first search. It is also used to traverse each node of this binary tree, or in this particular case the N-ary tree. Basically different from Bfs, it does not traverse each level at once. What it does is it goes to one level, then it goes to one child, then the child of that child before reaching null, and it returns the control to the parent, right? So first we will be traversing this particular node, then we'll go to 3, then we'll go to 5, right? And then we'll try to go to the next node which is null, we return the control to 5, we return the control to 3, then we go to this particular depth 6, then we return the control, go to the 2th node, then 4th node, and basically return the control to 1 and we return. So in order to do something depth wise, we basically have to use recursion. So these two approaches can be used to solve this problem, but I'll be solving the question through Bfs, which I find it quite easier to solve this. So let's just look at the approach. So I told you that we need to traverse each level, right? We will first be reaching the first node. So in order to use Bfs, we have to use a queue. So I'm making a queue. Now we basically insert the root node first because we have traversed it. So after inserting the root node, I check whether the queue is empty or not. Simple. Okay, so at each level we basically check the size of that level. We basically insert them. So we calculate the size of the queue. Then for that size, we basically extract the node and we check. Now this is an N-ary tree, right? N-ary tree basically holds a property. It stores the children as a list. As you can see, the childrens of a particular node, this node will be stored in a linked list, right? So in order to traverse a list, we basically use a for loop. We say that this is a for each loop. I say that if I want to traverse the children of this particular node, that will be 1 in this case. For all the nodes, for all the children of this particular node, I want to iterate over them, store them inside the queue child, right? Then we basically do nothing, we return. But what should we return? Actually, we are traversing each node, but we need to calculate the maximum depth, right? So what it does is we will first be at this level, then we'll be at this level, and the last will be at this level, right? So I need to increase level. Currently, when the root node is inserted, the level will be 0. But as we basically insert elements, right, the level will be increased. So we can say level 1 plus plus, and we finally return the level. Okay, so this is how BFS usually works. I just run this code. It is working fine. And always remember to add a base case that checks whether the root is 0 or not. Okay, and then submit it. Okay, it is working fine. 1 millisecond, 38.51%. Okay, so the idea was to solve this problem is to either use BFS or DFS. BFS and DFS both works fine, and BFS is quite easy to implement for me because it uses a simple queue and we are inserting every level, and as we reach every level we are basically increasing the count of the level, and we are here, as you can see, we are basically inserting children of each node, right? So I hope you like this video. Thank you so much.